security of the society. So such kind of a system is called as critical information infrastructure, and power is any country's prime such kind of an infrastructure. Then comes banking sector, then comes transportation sector, defense, communication, other kinds of federal municipal services, law enforcement, space research. In some order they are coming. But the first fundamental one is power. And because through this session we'll be talking about power and electric vehicles, which comes under transportation, e-mobility and transportation. So we need to understand that we are talking about cyber physical systems, which are in the top 3 ranking. So it becomes very important for us to know the know-hows of operating in such an environment. Well, let's see this. It's not very clear because it's a very big picture. We are trying to see the different layers. See, as electrical engineers, all these years, we have tried to understand the facilities coming out from a generation, the different kinds of generation, the different way you can transmit power, distribute power, and then at the customer end, what all are involved. All these things that we are able to physically see, there is a physical layer. Physically, you're seeing them, and they all constitute a physical layer. But along with this physical layer, there is something called as cyber layer also. And thereby, each of these equipments, generation level, transmission level, distribution level, the customer level, all of them in a way are cyber physical systems, and they are all connected to internet, directly, indirectly, through local area network, through www, or through Wi-Fi, through Zigbee, through Bluetooth, through RFIDs, different modes of.
Ma'am, your voice is not audible.
Okay, fine. Just a second. Not clear?
Madam, voice is audible, madam. Continue, madam.
Okay, fine. All right. So we are talking about the physical layer only all these years. And now there is a lot, it's not the recent one after Industrial Revolution 4.0. Even before that, we were operating with communicating with the control center, the SCADA control center. Okay, each of the regional electrical grid, southern regional electrical grid, north WRLDC, SRLDC, southern regional load dispatch center. These are some of the SCADA centers. Within a state, again, you have a lot of SCADA, the control centers, which take generation information, customer information. We try to see the overloading in your transmission system. All these things are already there. All of them, they use equipments like sensors, intelligent electronic devices, PLCs, remote terminal units, PMUs, all these things are there. They have a lot of communication making with the SCADA, gathering information at the physical layer and communicating to the SCADA through a cyber layer. And because of this, what is happening is, and this communication is happening on the generation front, transmission front, distribution front, even at a domestic front, at a residential or the customer front also. There is advanced metering infrastructure. There are a lot of devices within the house where there is internet connection, connectivity to your IoT devices, electrical vehicles. Okay, so all of them are connected directly or indirectly to SCADA through a communication platform. Now, the communication platform will change depending upon the device, right? So we just have to understand that we are not only integrated in terms of power flow, we are also integrated as a cyber flow, information flow. Now, when such things are happening, when there's a cyber related thing, what are the threats that we are supposed to understand? There are threats because of malware attacks, worms, virus. There are threats because of phishing emails, spammer emails. There are threats in our smartphones based on the applications that we are downloading. Many of the applications, apps, mobile apps that we download have got spywares. Okay, they are observing each and every sentence that we are talking, each and the camera, even though you're not able to see that the camera light is on. You think that we think that the camera is not functional, but it actually is. Okay, and in across the world there are many such cases of espionage, wherein without the permission of the customer, his private life is being tracked. Espionage, breaching of privacy has happened, and many such incidents have happened. There is a reason why I am referring to all these things. So smartphones are also threats, web applications, pirated sites, or some sites, wherein we assume that we are getting some content for free. There are no free lunches. We keep telling our children or our students, but that is very true also. Okay, so many times we get email that your loan is sanctioned or your verification is done. Just click this. All those emails, spam emails, web applications, all of them have a lot of malicious content. Social networking sites, they have their own method of hacking our lives. Then there are a lot of things where you have wireless attacks, botnets. We deal with botnets. Not every botnet is malicious. Like if I have to raise any issue in Amazon or in any other internet thing or IRCTC or anything, there is someone 24/7 who is responding to me. That's a botnet. It's not a physical person sitting right there and taking my questions. Of course, all the questions not able to be answered by a botnet is answered by a human, actual human being. But otherwise, we have lot of botnet penetration into our system to ease in life, to give a 24/7 assistance. To that level, it is perfectly fine. But the botnet we are treating as threat, it has a different role to play. There are lot of systems which are making a particular site busy. Okay, botnet is also a programmed computer which is trying to access a particular site, which is a genuine site. But too many people accessing a site at the same point in time would lead to, failure of the site. So many hits at the same point in time, it becomes an issue. So the botnets are used in a wrong way in that sense. There are threats like denial of service. There are threats like distributed denial of service. Okay, we'll come to understand some of them as we proceed. If you're talking about phishing, it's a fraudulent attempt to obtain sensitive information of data, your passwords. Botnets are networks of computers which are infected by malware, and they are controlled remotely by criminals or someone who wants to get some financial gain or attack a particular website or a country's intelligence information, power information, disrupt their services. Denial of service attack is something that occurs when legitimate users are denied of accessing information. It will also irritate a person. You all want to hear this lecture today. You have all planned your day, and if there is a denial of service attack on this link, then we will not be able to communicate. Okay, it's time based. It's so many other things also. So, uh, who normally are the threat? They could be in individuals just to show their superiority that they are very good hackers. It could be ex-employees, it could be rival industries, it could be rival countries, it could be hackers, cyber criminals, malware writers, politically motivated activities, not necessarily within the same country. It could be politically motivated on a global platform also. So these are all some of the threats, people who can create such threat. Haven't understood. I have been audible all these time. You could hear me, right?
Okay, ma'am. It's audible.
Yes, ma'am.
Yeah. So haven't understood that these are the threats and these are some of the entry points of threats. Let us go further and see some three important threats that world has recognized. Not that there are these only three threats that have happened through the electrical grid. There are many cyber threats that continuously keep happening. Only thing some countries declare sometimes, rarely. Many countries, many attacks are go undeclared for the simple reason that it will affect their country's share value, market value, currency value, and all that stuff. So therefore, it is not declared unless it is obvious. People don't talk about it, that they have been infected. I want to discuss three important, not necessarily important, but three threats that electrical grids have seen. You might be having a question in your mind. We are talking about electric vehicle. Why is this initialization happening on SCADA at a different higher level? I have a reason. First, let us understand what all happened on a SCADA level of thing at a bigger level. Then I will be able to make you appreciate how electrical vehicle disruption or an e-mobility cyber attack on an e-mobility is going to affect a system like grid. We will get connected to this small level to the actual major level, because we need to understand finally the philosophy is the same. You have to disrupt in one or the other means. Let us see three attacks that have happened on the electrical grid. World identifies 2000 cyber attack on Estonia. There is the northern side of Europe. There's a country, northern Europe. This country had been subjected to cyber attacks. And then second one is Stuxnet virus and Ukrainian grid failure. We'll see the three examples. There is this SCADA, there is this malicious virus which has disrupted your SCADA, your electrical grid. The first one that we are trying to refer to is the cyber attack on Estonia. This has actually targeted, the reason why this was done is that there was some disagreement between this country, Estonia, and Russia about the relocation of, bronze soldiers. Okay, of this, the capital is Stalin, and the bronze soldiers, there are some people. So there was an disagreement between the two countries. And Russia is suspected to be the person who has attacked this country. And in the process, what have they done? They have launched they have targeted the websites of Estonian organizations, their parliament, the banks, the ministries, newspapers, broadcasting agencies, and all of them. Suddenly they have been targeted and they started behaving in a peculiar manner. Their services got disrupted. Attacks were denial of service based attack and botnet based attacks. This was one of the first occurrence that went globally identified, and in a way we can say that it is the initiation of cyber warfare. Okay, we have just recently seen biological warfare. Cyber warfare has been just before that. People try all possible ways, use their intelligence in another way. The second important attack that the world had seen is Stuxnet. Stuxnet is an attack. What exactly happened is they have held a conference in one of the countries, and in the conference they have given a pen drive. As we get a bag, we get pen drive, we get booklets about the conference and certain material. So in this conference they have given pen drives. This pen drive, it has got some virus, Stuxnet virus. The greatness of this virus is that this virus remains dormant in case it doesn't find the target. This virus that was loaded on the pen drive, it would get activated only if the pen drive is connected to a computer which is controlling the nuclear power plant's centrifugal centrifugal system. If the computer to which USB is connected is controlling a centrifugal pump of a power plant or any centrifugal pump, only then this virus that is loaded on the USB, it gets activated. If this was put in a system of like ours, common man like you and me, this virus, you would never know that this USB had a virus called Stuxnet. Only if it is put in very specific locations, this virus would get activated. Otherwise, it's a dormant virus. And in the process, the prime suspects are these two. US and Israel have been the prime suspects. These cannot be proved anyway. It's only a suspect thing. And the major attack has happened on a nuclear power plant in Iran, wherein their centrifugal pump started working with different frequencies, low frequency, high frequency. And in that process, all its entire thing got disrupted. Okay, so this is how this USB infected virus, a virus which is put in a USB could infect tens of thousands of systems and many other things. And India is the third largest country which also got affected because of this Stuxnet virus. And now almost everyone is able, you have the Stuxnet code on your internet. There is also students are given as mini projects to write an antivirus code for that Stuxnet code. Okay, they put a centrifuge and they see how this Stuxnet code is going to impact the centrifuge's frequency, and how the antivirus of that Stuxnet is all available online, open domain. So this is one of the another notable cyber attack that the world has seen. And in India also, we could see that there were some solar panels that were failing in some 2010, and it has infected about 10,000 computers. Okay, at Gujarat, Haryana, electricity departments, ONGC, and these are some of the reports. These are these are not my conclusions. These are some of the reports that got generated in 2012. 2 years from then, we started an understanding. Maybe did it also affect, because there were also Indians which went to the conference and collected those pen drives. Then there's a third attack, Ukrainian attack. This video of this attack is with me. I'm going to show the video. Before that, I'm going to tell you what exactly happened with this Ukrainian attack. A phishing email had been sent to one of the, or maybe many employees would have received such emails, but one or two employees have opened those kind of an email, phishing email, which has that virus, code and the link rather. Once they have opened that email, the virus had started affecting or taking hold of the system. And any problem? Yeah. Okay. They have started taking hold of the system. What this, cyber persons have done, the cyber attacker has done is they have, and by the way, email is sent to a person sitting in a control center, distribution control center. To that, the email is sent. The person has opened that email. Virus attack has happened. The person had no clue that such a thing is happening. A mimic, a same system of the single line diagram and all the controls that are there from that control center has been redrawn by the cyber attacker, and a mimic of this entire system has been made by the cyber attacker. On one fine day, what they have done is, at the evening time when the shift of that person has got over, one of the shifts of the control system engineers got over, just before they were leaving, they have seen a very peculiar behavior, that the mouse started disconnecting circuit breakers one by one, one by one. This person sitting in the control center, he was trying to take control of the mouse and trying to stop, but his mouse lost control. He did not have any control on the mouse in his substation. So this way, lot of infrastructure had been, disconnected, and leading to a major catastrophe. And this is a very well-known Ukrainian attack. Okay. And finally, even the password of the systems have been changed, and entire system has been mimicked, recreated. And the persons actually sitting in the control center, they lost control, and the persons who are doing cyber attack, they took full control of the system, and they have disconnected all the important feeder lines and disrupted the power. So there is this video. I'll just you can there's no audio to it. It's just this thing. You can take a look. So they thought that IT guys themselves are doing it, but it is not the IT guy who did it. It is the attacker who had taken control of their grid, and they have disrupted thousands of feeder lines, many feeder lines, disrupted huge services. So these are some of the examples that the world has seen on attacks on SCADA systems. Now let us understand how electrical vehicle and what impact will an electrical vehicle have. What is a cyber attack that is possible on electric vehicle? Which are the points through which an EV can be hacked? How will it affect the grid eventually? Let's understand that part now, which is as such the topic that I have been given to deliver. But without the background that I just told, I thought you cannot connect the relevance and the catastrophe to what magnitude an EV hacking would lead to. So we all know that we are talking about smart grids, and EV, which is a smart mobility or e-transportation, plays a very important role. If you are trying to see an electrical vehicle or a plug-in hybrid electric vehicle, you have got many components in it. In that, this is the only safest component, if I should say. Fuel tanker. This is just you're going to fill your fuel, and the indicator tells you how much of fuel reserve is available in your car. All the other things that are there in your electrical car or your hybrid electric vehicle, you have got lot of there is a battery here, there is a battery energy management system, there is traction battery pack, there is controls within the car, which is trying to control the battery state of charge, identify that. It is going to switch between when should the battery discharge, when should the fuel be the source of driving the car, the thermal aspects of the system, the converters, the firings, power electronic controls within this. So there is a lot of communication that is happening within the car. There is a lot of communication that happens from the car to the outside world also. We will understand one by one. So within this hybrid electric vehicle, you have got so many subcomponents. And this is one of the subcomponent, the charger port. This is one of the areas through which, yes, this is one of the areas through which we will be able to have a cyber attack or a possible threat. If you see the electric vehicle architecture, we will be able to see that within the car, there is something called as a CAN bus protocol, which means controlled area network protocol. This CAN bus protocol is used to communicate between the systems within your EV. Okay, it communicates to see the battery module, what is the state of charge of the battery, what is the thermal aspects of the battery, what is the state of health, the deep discharge, the C rate of the battery, and then what is the condition of the compressor, the heater, the motor, the transmission system, and then the accelerator, brake, everything. Some of the things are being controlled, and there is a lot of communication also happening within your car. And there is a communication from the car to your charging point whenever it is charged at a charging station. So this architecture is just to make you realize, because we will be talking about CAN bus protocol only, because this is the network within a car, which once it is tampered or hacked, a lot of disruptions can be made in a car, in an EV. So cyber threats that can happen in smart electrical vehicles, you have your battery complete pack. Okay, there is a continuous monitoring of the cell chemistry. Then if there is an attacker who is aiming at this car when it is getting charged or when it is communicating with different other external things, if an attacker is able to crack this CAN bus protocol or any other protocol, communication protocol, then they will be able to impact the physical well-being of the person, the financial well-being of the person, and also the strategic well-being of the person or the individual. So this attack can create so much of impact. In the car, there are many subsystems. Subsystems like the door module, window actuator, mirror, okay, then all of them, and there are many other modules also. All of these complex subsystems are communicating using a canvas protocol. The communications that take place between an electrical vehicle and a charging station are, when the electrical vehicle is connected to a charging station, there would be an RFID reading happening in the charging station. There should be an RFID reader on your electrical vehicle. That verification is to be done. There is a Bluetooth also that could get connected. There is cellular connection for tracking the global positioning system, GPS location of the car. You might also be connected to a cellular tower. Okay, there are some other J1772 protocols of communication, okay, between the electrical charging that is happening, Chemido and this. Then there is in the battery, then there's a all of this communication, it can be controlled with the CAN bus. This charging point itself, it gets power from the electrical grid or a solar powered system, okay, and this is connected with a Wi-Fi or cellular connection, and it is used in battery energy management system. So there are so many subsystems just in the process of charging your car from a charging station, charging point. Okay, there's so much of communication happening. So as I was just telling you, communication within the car is from a canvas protocol. There will be other communications like cloud-based services also are there, cellular and cloud-based, RFID based. Then there's a Bluetooth, Zigbee, Wi-Fi. All of these communications are there. This is within the car and the relation that it holds with the charging point. There is a lot of communication which also happens external to the car. It could be car, vehicle to grid communication, vehicle to load, vehicle to vehicle. If are the different other communications, then you can just see there is a car. Within them, there are many sensor points and they may be communicating using onboard sensors. There could be a car, okay, there could be this gate where, of course this car is moving backwards. If there is a car that is coming towards it, by like fast tag, what I'm trying to say is like a fast tag. On its own, we are able to pay the toll. Okay, so there is a communication between car and your this. If it's an automated car, then the car automatically stops seeing the red light. So there is a communication between the two. There is a communication between a car, an automated or a semi-automated car with the policemen. There is a communication happening between car to car. Okay, if of course you should be able to come to that stage. And then there is communication between the mobile tower, okay, and all these things. So there is a huge amount of communication that is external to your vehicle also, vehicle to vehicle, vehicle to network, vehicle to house, and all of that, to the charging station, to the aggregator, okay, EV aggregator. So now through this diagram, I want to make you understand that though we are talking about having an electrical vehicle, and if there is a hack that has happened on electrical vehicle, how will it impact my grid? Holistically, if I have to understand that, this is the diagram through which I can make you understand. Okay, see, let us start from here. Your electrical vehicle. An electric vehicle has battery pack, onboard charger. You have your power electronic systems, converters, IC engine, wheels, all of these things. Okay, and there is something called as this Chedimo, Tesla, or whatever. There are some protocols, and these are the charging, that point. Now, this electrical vehicle, it is connecting to your electrical vehicle charging station. It starts, this is the first point through which you will be able to penetrate into the grid connection. Electric vehicle with all its subsystems, through its charger, it gets connected to the electric vehicle charging station. It could be a DC charging station, it could be an AC charging station. So once that it is connected to this charging station, there will basically idea is to charge your battery. If you want a fast charging, you go for a DC charging. If you want if you have time, and if your car allows only AC charging, through AC charging and onboard controllers and adapters, you can charge your battery. So essentially, electric vehicle, when it is getting interconnected to the charging station, there is a possibility of interaction between the EV and the charging station. At this location, there are many attacks that can be planned. Attacks with respect to payment related attacks, attacks with respect to some information which is incorrect, information about the electrical vehicle status, battery status, which could go incorrect. Okay, so this is one intersection point wherein a cyber attack is possible, and these are planned also. Now, this electrical vehicle charging station, in turn, takes power. This DC charging or AC charge, like petrol pump, no? It is like a DC petrol pump, DC charging petrol pump. So it gets power from the electrical grid or a renewable source. So finally, this is connected to the electrical grid, maybe at 11 kV, 33 kV, 66 kV, all of that, any of that. So this is where they are interconnected. Electric vehicle interconnected with charging station, and also interconnected with the grid. These are all the things that are they're lying on the physical layer. Now, at each point, at the grid point, at the EV charging station point, at the electrical vehicle point, there is so much of communication happening within the systems. Okay. So if you try to see in electrical vehicle, what is all the communication information that is being exchanged? Just see, just let's go here. This is the physical layer. Now we are talking about the cyber layer, cyber security, or the communication layer. Communication layer, coming to the electrical vehicle, you have charge control unit, you have airbag control unit, you have intra-vehicle infotainment system. You have a lot of entertainment within your vehicle. Not only EV, any vehicle, you have a lot of infotainment and entertainment things. Information also is there. A lot of information about your GPS location, your next destination point, the nearest hotels, the nearest restaurants, and so many things are available. Okay, so all that infotainment systems are available in that. Along with that, there is a monitoring of the engine, monitoring of the battery status, monitoring of the tire pressure. Of course, as I told you, as you go up and up the vehicle, the complexity is also going to become higher. The AC control units and all of these things. These are some of the communicating aspects within your electrical vehicle. And which are the ports that are available? USB port, CDs are no more available today, but USB port is there. Then you have OBD port. We'll try to understand what is it. These are all the ports. These are all the communication units that are there within your EV. When you're talking about electrical vehicle charging station, you have got, this is the information that is there. EV charging station has its own meters, telemetering terminals. Okay, there's a then RFID reader is there. Okay, whenever the Chedimo is connected to your EV, there is this here also, there is an RFID, here also there is an RFID. There is unique ID. Upon verification only, charging starts taking place. Based upon this RFID only, your bill gets generated, and so many things happen. So RFID is going to play a very important role. So in your electric vehicle charging station, you have the RFIDs, magnetic cards, authentication of the payment. There is there, external interfaces are there, LAN controls are there, power converter status is being established or monitored. There's a so many things. Again, the what do you call the this whatever picture is taken, it is taken from Tesla based EV. So therefore, this word Tesla is there, but it is not specific to Tesla. It could be any person, it could be Tata's, it could be Mahindra's, it could be any other persons also. Every EV manufacturer has his or her own communication protocols, okay, that gets maintained. So within your electrical vehicle charging station, you have got all these things, sensors and communication networks. When it comes to your power grid, okay, there is distribution system operator and transmission system operator. All this data they will be requiring. There are sensors, there are CTPTs, and there are IEDs, intelligent electronic devices. All of them are trying to CPMUs at some places. All of them are trying to give information to the power grid operator. This is cyber layer, and which is internal to that. Now in the cyber layer, again there is external to the cyber layer, which is communicating to distribution aggregator, DG aggregator, distributed response aggregator, then building energy management system, okay, smartphones, third-party sites, EV fleet services, vehicles, OEMs, original equipment manufacturers, on-site human-machine interfaces. There are so many things. Some of them are sitting on the cloud also, servers or clouds. So all these things, there's a communication happening. Okay. So if you try to understand this entire system, it is a multi-level cyber physical system nexus of EVs, EV charging stations, and power grid. So these three are interconnected. If you remember my just an explanation of Stuxnet attack. Stuxnet attack, the virus would have never become active if he would have not seen a centrifugal system. Similarly, if there is a penetration of a virus inside your electric vehicle is not a very powerful computer. It's a simple machine which is essentially trying to improve its efficiency in the drivetrain, with transmission systems, to have better battery. We have less thought about its cyber security aspects, because all our energies have been in improvising the EV efficiency to reduce the uncertainty for a driver, that the person should not get stuck in the middle of a highway. Okay, so all our focus is to improve the electrical and the mechanical efficiency of the system. But considering that these ports like USB ports and some of the things, they can be a root cause for some of the attacks, and that attack may be within your car, it would never become activated. The virus might never get activated until and unless it is connected to a system for which the virus is made for to disrupt. So therefore, because it's an interconnected system of communication, there are chances of attacks also. So if you see the electric vehicle ecosystem, electric vehicle communicates with your charging station communicates with your energy distributors communicate with your suppliers, charging stations also communicate with the charging point operator, e-roaming operator, yes, and also it is communicating with an e-mobility service provider. So this is the electric vehicle ecosystem that we are dealing with. As we understand, we have completely changed from the mechanical control to electronic control, and modern vehicles, they are controlled and they work on networks. And networks, once you have, you are prone to attacks. The fundamental thing that is in your system is a CAN bus protocol, bus protocol, and CAN bus connects all the EV components responsible for its operation. it has access, the CAN bus protocol, it has access to the onboard diagnostics port. Okay, from this port only all the communication is happening within the vehicle, and anyone who can control the flow of data by sending a data packet, they will be able to through an electronic control unit. You have to send data could be virus data, it could be good data, healthy data. So once you are able to send the data through your electronic control unit, ECU, this can happen through a canvas. So the data packets could be about controlling the reference speed, could be controlling the braking system, could be controlling the steering system. And as I've told you at the initial level also, this is something that we're talking about semi-automatic and fully automatic cars. Okay, even if it is not electrical vehicle, still the chances of attacks are there. EV has more complications, that's all. Otherwise, once your car is connected or is made a cyber physical system, all this holds good. Then there is something called as an open access port, and there is an entry through that port also. So these are some of the points: CAN bus, onboard diagnostics, then electronic control unit. If you are able to penetrate into these, then cyber vulnerabilities, they get magnified and risks also increase. Whenever they try to see a cyber attack model, they keep in mind something called as STRIDE, STRIDE. These are some of the most popular cyber attacks that are done, not only on the electric vehicle, as such also. One is spoofing. The S stands for spoofing, the first letter S. Spoofing essentially as if you're disguising yourself as a legitimate source of process. See, we are getting a lot of phone calls saying that I come from so-and-so credit card, I come from so-and-so debit card, and you give me your OTP or you won something. All these spoofing messages, spoofing emails, we have been receiving for a very long time. Some of us who have also experienced a financial loss, uh, some of the payment gateways, UPI gateways, and certain things. Okay, so this is one of the methods through which a cyber attack can happen. And Ukrainian 2015 attack is such a spoofing attack only, wherein a phishing email spear phishing emails was accessed, and which led to the disruption. Now, I start altering firmware, there's a hardware, there's a software sitting on your system. It could be car, it could be any of that. There are updates that are definitely going to happen. See updates on WhatsApp, it's on all our apps. So as well on systems, updations that are there. To the latest, if this firmware updation to ensure that the destruction of the data or process, it becomes a tampering. So the two means unauthorized or destruction of data on a basic measurement unit, remote terminal unit, remote terminal unit phase. EMU is connected. So there's a amount of communication and the data with EMU. So as it is with an RTU, all are time stamped and interconnected systems. So if you're able to tamper data, the healthy condition, unhealthy condition, both can raise panic. Okay? And you might want to be done. So tampering is such an attack. It denotes responsible behavior. Performed. This can happen at the right incentives to be given for the lot of education. This information informative disclosure by unauthorized person. Okay. The information is not smart and I kind of attack, informative disclosure attack. Smart meter which is at your domestic location or industrial location, the gradual use every at some the electricity usage rate. That data, that information is itself flagged as a spy. It would tell the time when you are not in the house, the time when you are in the house, the time when you are gone on holiday, and all that. Once you know you are not available in the house, there can be possibility of a robbery in the house. There is some other kind of financial damage that could take place. So, this information can be used in many ways. Kind of service is where an authorized entity is prohibited. That an attack he gave extra privileges, implementing protocols. It means if someone is able to hack your Canvas protocol, it will make that protocol behave and become new, privileges it is going to get, which is called. Okay, suddenly it writes some, uh, vibrating, or if your windshields are raised or lowered differently when it's accessed by someone, all these things are all disruptions. Your steering is taken control suddenly, and you are completely lost control on the steering. These are all some of the things that can be done. Okay. So whenever a cyber attack is planned, they seek for SRIDs, spoofing, tampering, repudiation, information disclosure, DOS, and elevation of privilege. Okay, so with that, what can happen is you will be able to take control through your Canvas or these protocols, energy management system, the torque of your wheel, the regenerative braking system that can be brought into access, the battery units, its present state of charge, then the electronic systems inside your car. All these can be taken control of. The powertrain, okay, and the auto driving system, okay, cruise control system, lane keeping assistance, okay, your road, how it is next, which is a better route to go. Maybe one route has more traffic. All that lane assistance, all of them can be hampered. Automatic parking. Okay, there are also systems where you can have automatic parking within a particular area. The system, the car will be able to itself tell that there is a parking slot available. You can also have collision avoidance systems. Cars within some vicinity of some meters or some rather, I would say, they would beep. Even when we are right now, also when we are trying to take reverse, then there is an collision assistance beeping, and the front camera. If these things are hacked and you are given a wrong information of the actual picture, it would lead to disruption. It would lead to huge issues. So all of these systems, they can be hacked. Once CAN or LIN or FlexRay, these are the protocols used by different equipment manufacturers, car manufacturers. If they are all hacked, it would lead to these kind of issues in a battery system, braking system, motors, transmission systems. So this cyber attacker, he can affect all of them. Okay. Through, they can attack the gateways, they can attack the steering, braking. Okay, vehicle to vehicle embedded telemetrics can be attacked. Door control, seat control, climate control, temperature within your car, every component and subcomponent of a car can be mal operated. See, whenever there is an exchange of data, what is the data that get exchanged between electric vehicle and a charging station? Let us understand that. One is the customer ID or the vehicle ID or the charger ID. You have your charger, DC or AC charger. Its ID is one of the information that is exchanged as or is informed to the charging station. Okay, which is this is the information which is unique identification number by the user vehicle. Okay, this is one information that is being exchanged. And command controls. Okay, controls issuing or receiving of vehicle or charger. Okay, now they will say that you can keep your charger. Now we are ready to charge. Okay, there are some firmware, software downloads and updates that also get exchanged. Okay, so if someone is able to interpret and misguide on these things, it will lead to a lot of problem. Let us understand the vulnerabilities of EVs. CAN bus vulnerabilities. You have this on-board diagnostics port, okay, within the CAN bus. With that, if there is a wild infiltration service aided, it would lead to a vulnerability. Okay, because if you see within your car, you have onboard diagnostics, Bluetooth, CD, DVD, or USB. Okay, you have tire pressure related thing. Okay, within that CAN vehicle networks. So all these things physically, if they are accessed, then and intercepted, then it leads to major catastrophe. Now the question that you and I might be asking, when will this car is with me, how can someone put virus code into my car? It's an independent resource. Of course it can be put. The car through its lifetime, it goes for servicing. It has your USB port. It has so many other kinds of things. So the mechanic, if having a malintention, of course mechanic himself might not be equipped enough, with the aid coming from an external cyber infiltrator, they will be able to put, okay, the virus code through your USB port into the car. Okay, code is written in such a way that it might run your music system pretty well, all the songs that are loaded on your USB, but it can take a lot of data. It can change your GPS settings. It can change your battery energy management settings and all that. Even while the wallet, when it can change the RFID information, tamper the RFID information. It will, maybe you can see that your wallet, from your wallet, only 1,000 rupees is deducted, but something else is also deducted, or after that, for subsequently, money is getting deducted. Auto control on your bank account. Okay, I'm sure we all are hearing that don't try to charge your mobiles from a public, places, public locations like airport, railway stations, or such places. Don't charge your mobile phone with the USB cables available in the public thing, for the reason that so many people got their money debited without their knowledge. Okay, so what is there? It's a port only, no? It has some virus fed on it. So once your phone is connected to that, your laptop is connected to that port, specifically phone, all your your phone is going to be hacked by that system, and they're very much prevalent nowadays. There's no surprise on that. Once your phone is hacked, now it's up to the person what worst level the person wants to take it further. So similarly, the car has USB port, and if that USB port is getting infected with a virus code, then rest what they will do with the car is up to the person's imagination. Then you connect your port, you connect your phone also to your port. Through your phone, you control the uh, uh, household accessories, your fan, your EV. I mean, so many things you can control from your phone. So from this USB port, infected USB port, you're controlling the car things. You're also controlling your phone, your mobile, your payment, so many things. Everything that you connect to that port, which you have given it for service, and that time it got hacked. Rest, whatever you connect to that port would get hacked. The code is written in such a way. Okay. And your car is not a great computer to now probably eventually will have antivirus also on your car and so many things. It's going to become like a mini, like our phones were initially only to make a call. Now it became camera, it became everything mini computer. Similar way, if your car also becomes mini computer, you have to have every kind of cyber protection also on your car when the day when we go to that level of usage. Okay, so basically canvas, there are a lot of vulnerabilities. Okay, and then there are a lot of vulnerabilities also. EV to X could be USB port, SD card ports, CD-ROM, ROM, DVD-ROMs, headphone jackets. Okay, then touch screens. All of these are the physical access points to your intra-vehicular infotainment, and electronic control unit. So these are all the access points. This is the points from where your virus code can be put on your EV. USB ports, SD cards, phone jacks, touch screens. I mean, finally it is the USB port at the end of the day. And this would disrupt roadside infrastructure, uh, original equipment manufacturers, vendors. Okay, the malicious devices inserted into these ports enable an attacker to inject persistent malware into the system. Okay, and once this malware is infecting your EV at various points, it is going to affect the supply chain and maintenance also. It could also affect the smartphone Ethernet terminals, which are eventually getting connected to your EV. Okay, so this is the actual access point in your electric vehicles. There are a lot of vulnerabilities that further happen. Once your RFID tag is, it's on a chip. Okay, so people can make such a chip again by reverse engineering. I am a person from a competent car company, and I really don't know how a very well-known car company is able to upkeep its cyber security of its car. So what I will do, when instead of taking names unnecessarily, I'm just taking car, a reputed company, and yet to be developed company, reputation wise. So this yet to be developed company is going to hack the RFID chip of this reputed company, already reputed company. It is going to do reverse engineering. A, learning all that, and B, disrupting the reputed company's RFID tagging or its chip. So it can do both. One is learning from the chip and disrupting the chip. Okay, so these are some of the things that can be done. Eavesdropping, which is nothing but unauthorized hearing of the data. Okay, this is a very important thing that keeps happening very regularly. Eavesdropping. Okay, then there's a denial of service, man in the middle attack. Man in the middle attacks are also very famous attacks. Okay, there is someone in between whom we are not able to see, who is hearing us, all the important data that we are communicating, seeing all the data packets, and disrupting and sending it to the receiver with a different encryption. All these things are possible. Okay, remotely hijacking your machine, your car. That remote hijacking, it's also very possible. Okay, a semi automatic or a fully automatic car, which is taking rest, and it's a night time. Morning you will end up in some place which you have not expected. Okay, there are huge attacks of hijacking on cloud infrastructure. Okay, all of that is there. So some threats that you can imagine once your canvas protocol is hacked through your physical systems, physical ports, is start stop of your car, steering locking, battery charging, access to the charging stations, RFID detection, payment gateways, access to reversing of your car. Now you have full control of your car, and if with malicious intention, I can go to any extent as a cyber attacker. Access to your GPS coordinates also can be manipulated. I'm going on a new route, and someone has manipulated the GPS coordinates. I might go somewhere, a lone place where the person could have been looted also. Okay, so then keyless access. Okay, With that, if I'm able to have that RFID and a keyless access, someone can mimic my car wireless key, and I'll park it in the parking lot, go to the mall. By the time I come back, neither my car is there nor what am I going to do with the lock? My lock has already been mimicked, and someone has taken my car and has left. So the keyless access has its own threats. The Bluetooth module, the wipers, access to the wipers, okay, battery charging status, all of these things, they can be nicely targeted by a cyber attacker. Okay, so the potential threats could be threats in the man of the middle, payment frauds, tracking issues, intentional overcharging of your battery, intentional discharging of your battery. Your battery would get discharged even when you are not using your battery. Okay, and denial of service, malware, and all these things. These are all taken from various sources. Okay, Department of Energy, technical report on EV and charging, cybersecurity report by US Department of Energy. So these are all the possibilities that can happen. I'll just show a particular video, which is going to, it's a big video. It's 11-minute video. Will not take the 11 minute. I'll just drop at a small location where a person is losing his steering control and the car is getting reversed on its own. The car stops on its own without any manual intervention. It's being hacked. The campus protocol has been hacked. It's a demonstrative thing. It's not really hacked. It's demonstration that it can be hacked.
You can buy the components any place. Right now, the size of the CHT is like an iPhone, more or less, but it can be really smaller. Car hacking is a very holes in your car were secure. Today, when you lock the doors on your car, your personal information is actually stored out in another cloud services. All this never hacks the car remotely.
Today is actually the first day I've had a chance to test.
So you're testing it on us.
This is my first time actually testing live with the person on the car. In this case, I am controlling the CAN bus remotely over the cellular networks. The only thing coming off my laptop is my GSM. We had to move the telematics unit from a newer setup to this because these don't come with control it remotely. What I'm going to do next little bit is actually remotely stop the engine of the vehicle.
Okay. Oh, all right. Engine's dead. I can't move. I'm stuck. All right. Bad time to go uphill.
I'm going to run through to the different controls of the car.
So it's locked now.
So I'm going to send the unlock command. Sending sequence sent. Give it a second to set up the network. Not bad. Let's see what else we can do. And stop.
Cool. You can start and stop the engine from the other side of the parking lot. Well, I mean, like, okay, engine's dead. We're moving backwards now. The steering wheel there's no power steering. It's a little frightening. Thank God this is an empty parking lot.
So this is the small example of how comfortably a car was hacked. Okay. Now let's come to the last segment of the entire conversation or the lecture. Now that we have understood that there is a lot of complexity in EV charging ecosystem, there is a lot of complexity in connecting our e-transportation to the cyber physical system. What should be the methods in which we are going to mitigate and what are the proposed solutions? Just the way when we are someone is launching an electric vehicle, they do a lot of tests. Tests are environmental test, vibration test, smash test, okay, EMI, EMC, durability, safety tests. So safety tests happen, crash tests, all these things happen based on which they see that a particular car, like for example, worldwide it is renowned, it is known that Toyota cars are one of the most safest cars. Even Tata is also claiming one of its segment to be very safe. So we try to do that kind of a safety tests on a car. Okay. Similarly, the same car, on one side, it has to be safe in terms of its crash, its angle, its slope, the kind of road that it goes on, muddy road or a well road. That tests are anyway inevitable. Okay. Along with those tests, all the upcoming cars should also be cyber security tests also should be conducted on them. Okay, chip set tests, penetration, will a virus penetrate into my car, how safe would my car discard it, what are the vulnerability assessments in a particular car. All these cyber security tests also have to be compliance also has to be done. And there are a lot of standards that they are available. There are standards available to accreditate a car. Okay, but the cyber standards that are there are done by NIST. Many countries have their own standards. They are meant to identify, protect, detect, respond, and recover. They need to identify what are the systems that need to be protected. They need to protect the system. Okay, and they have to detect in case of there are any cyber security incidents that have to be detected. Sometimes that completely goes unnoticed. That also is not a good thing. So they have to detect the cybersecurity incidents. They have to respond, develop techniques to defend such incidents, and recover in case. Quickly, you have to be able to recover from that attack, so that the customer is not, losing his time, energy, and is not angry. Reliability of your company is retained. So cyber security certifications are already in place country to country. Okay, these are some of the names of such cybersecurity compliances that every car, which is semi or fully automatic, has to be compliance with. If you see the statistics, we see that there are many channels through which attacking has happened. Okay, and like USB dongle, OBD dongle, telemetry control, Bluetooth, USB ports, sensors, Wi-Fi, cellular networks, infotainment, mobile applications, keyless entries, servers. These are some of the percentage, how much percentage of which physical system has been used to create the attack. Then there is an impact of theft, that is how much is happening. Okay, policy violation is happening, 2.5% theft of valuables within the car. With this attack, they're able to open the door of the car and they're able to carry out theft in the car. Manipulation of a car is misguided. There is a financial fraud that's happening. Service disruption, location tracking. Someone is able to track the car owner's location. That is sometimes not accepted. Many times not accepted, or every time not accepted. So there is a data breach, then unauthorized control that is happening. So all these things are good percentages. Okay, and these are the number of attacks that are happening: wired attack, wireless attack, and it's increasing. Then see, these are all the things that are taking place in the commercial charging station. So this is your charging thing. It's connected to the station, and there can be an attack. Then there could be an attacker sitting and taking all your money based on a different thing. The Casper Sky Labs, Tesla, all of them, they have advertised and asked people to find out cyber vulnerabilities in their cars. Okay, so there is Casper Sky, which is a very well-known antivirus software owner. So they are also working on antivirus on vehicles. Hackers, they could conquer Tesla's in-car web browser and win a Model 3. So Tesla has itself has made contests. Okay, contests are made by Facebook, Google, Amazon. I mean, these people also. So is Tesla. It has also given huge monies, asked people to identify a bug in their car. Okay, and people have won money with that. Okay, it is indirectly inviting people to test their car and see how cyber wise safe that car is, that vehicle is. So this is all about the cyber security aspects of electrical vehicles. Not only Internet of Thing being one of the prime areas. As a researcher, as I see faculty development program, so I also want to just highlight the other related research areas. Internet of Energy is one of the most niche areas now people are talking about. It is not very different to what Internet of Thing was doing to us. Internet of Energy is very specific to energy related applications, wherein energy application, all of them are acting as a cyber physical systems. Okay, there are a lot of applications in IoE, asset management, load balancing, shifting, peer energy trading, net zero energy building, decarbonization, earning credit points on that. Someone is interested in trading, energy trading, it's for them. If you last slide, this is, of course, this is a research area under the head of energy. Okay, every equipment today is a cycle system, integrated system. The same it is the just is one of them. So the conclusion is those who are in indicators through tracking, filtering, they can unauthorized automobile attack to commercial applications. So these are some of the fundamental things that, and all of these things are possible when our cars. Okay? Everything is possible in the cars that we have. Good amount. So with that, I stop and talk. Any question?
Hello.
Yes.
Dear participants, if you have any discussions or queries, please address to the speaker. So there are no queries. Thank you, ma'am, for your valuable insights.
Yeah. So I can disconnect now. Yeah. So thank you. Thank you to Vvit for this opportunity. Thank you.
Thank you, ma'am.
The next session, that is the fourth session of FDP, will be held at 1:30 on 21st February, that is today. Thank you all.